This video is going to explain to you how to work your way through the assignment 2 for Unit 12. That's the programming assignment. The first assignment that you have already hopefully done tells me that you understand some of the programming language concepts. In this project, you're going to be creating a program, designing, creating and testing, and then evaluating a program from a given spec. So I've broken down what you need to do kind of in colour code. So there's the planning part, the building part, and then the review part. And you can see that there's some sort of easier tasks, and then it gets more complex, and then it gets even deeper, higher level thinking. So that's how it's broken down. I'm not allowed to specifically say what's pass, merit and distinction. The wording hopefully in the assignment and the criteria will help you have an idea if you need to know. The reason we can't tell you what is pass, merit and distinction is that we would like to help you to achieve the very most you can. So we want you to go as far as possible. So the planning part overall is that you explain, you've read the scenario, that's very important. Then you explain from that what you see as the purpose of the project that you're going to do. Why are you doing it? And what must it have? What are the requirements? That means, what does it have to make sure it has done what it was asked to do? Then you're asked to unpack the project, and as you're planning, you're asked to break down how you will solve this problem. So you have to say what input you expect to have, what output will come. So what do you expect the user to say, to type in? What information do they expect to come out from it? And what process, what are you going to have to do to the input to convert it to the output? What calculation or what changes do you have to do in the middle so that the user gets out what they wanted? As an extension of that, you should also include some advanced planning documents such as pseudocode and flowcharts. You should also, in both of these, include a test plan to say how you are going to show what's worked and to check that it all works all the way through. There's that slightly higher level thinking, the alternative options that you could choose, and at the highest level, at the extending of that further, explain, justify just what is it that you are doing at each step and why each of those parts meets the purpose and the requirements for the project. And what is it that is stopping you from doing an even more complex project? It could be to do with the language, or your equipment, or the time, or the team who are working for you. At the next part, you need to, the core, what you have to do is you have to build a program, and you have to test the program. At a higher level, you're going to go and you're going to ask people for feedback. That could be family members, and make improvements and show you've done that. And then you, at the very highest level, you're going to make even further improvements and explain why you made those changes and why it makes it better. Finally, what you're going to do is you're going to review your program. You're going to explain how your program solves the original requirements. So evidence that this shows that, this shows that. Reviewing how well the program meets the specification. This time you're reviewing. You're actually going into more detail and how you improved it to make it better than your original. And then finally, if you are highest level, and notice these are all really extensions. They shouldn't be separate. These are really, we're showing that we can work at our core level. You're extending that further and your thinking is deeper. And here for the highest level, you are evaluating your program. You are much more critical of what you did in relation to the spec, including how the quality of the programming, for its usability, renewable, that you could pass it on, things like that, and how you would improve that program further. So I've broken this down. We have the passes: describe the purpose and user requirements. So what's the purpose? What's it for? What do you need to have? What are you going to include in it? What's your planning documentation? You define the problem. You explain what the solution is, how it's going to be broken down. Perhaps what you will, what language you will use that's already, you are taking pre-written, things like print and input, and what your test plan will look like. Then you develop the program, and then you test it, and then you review it. That's at the most basic. If your merit work is that you're coming in with alternative solutions, your proposed solution is more detailed with pseudocode, flowcharts, things like that, and you start to include your test data before you begin your program. Then you make sure that the program is actually working, and you test it, and you get feedback, and you use that to improve it, and you make sure any faults are fixed, and you review how and in what ways the program met the original requirements, using that feedback and constraints, things that you couldn't change, things you were stuck working against. And that higher level, justifying the design decisions, justify why is that project going to, in what ways you are fulfilling the purpose, and any constraints you're in. Your program is improved. It's not just the first program you did. You've improved it, you've made it better, and you explain how that has happened. And you evaluate, you judge, you justify how you wrote the program and any changes you made, why those are better. You're showing your high level thinking and how you would improve it further. So this sheet should help you. You should be able to answer these questions to help you know what you need to be putting in here. You, in the first part, you are working as an analyst, so you're pretending that you've spoken to the client, you've got an understanding of what they need, and you need to write that down to explain to someone else who might take this project on. It seems sometimes like, well, I know what I need to do, it's written down, but you are writing this in your own words. You would also maybe check this against the client to make sure that you've understood the project properly. So you write down their requirements, what must be included, and what's the purpose, what does it have to do, what jobs must it do. You need to write what's called a problem definition statement. That means you explain what the business has asked for, so what is it that you need? You need then to work through, explain again for the client to understand, but really maybe for the programmer who you might pass this on to, what information is going to come in at the start or during the program. It would help if you tell them what they might call those variables so they don't get confused, and what sort of information you expect it to be. Is it going to be words as a string, whole numbers as an integer, or maybe numbers with decimal places, what we call floating point. You're going to say what sort of information is coming out. So what information will come out? What's the answer you're giving the program, the user? It would help, again, if you use name what that variable might be called for each one, so that the programmer can just get on and do it, and how that information will be stored. Is it whole numbers, decimal numbers, or words? You're going to explain in words what the process, the calculation or the change that will happen from the input to make the output. And you're just going to write in words just a little summary of what your program is broadly going to do. And then also, this is a little bit odd in our language, in Python, but what words are you using that are already written in Python? Those are the ones that have the brackets around the part of the information that comes after. Print, for example, or input are two of those. And you need to give a test plan before you begin. You are the analyst. You need to tell the programmer what they need to test. What should be input or done with the program. It's lots of little tiny steps. What values you might type in or put in, and what you expect to happen. Again, you are the analyst, you've spoken to the programmer, to the client, and you have got information about what would look right, how the program is working. It might include things you expect to put in and expect the program to fail. So you write a plan like this. Could also include dates. So this is saying when the program is running, test each of these things. You need about 10 tests. It's a slightly higher level of thinking. What you're going to do is you're going to make that information slightly more detailed. You could perhaps use pseudocode, which is a sort of semi-English, semi-programming language, a flowchart, and show that you've thought around this by giving a couple of other ways that this problem might be solved. These don't need to be programming solutions. They might be. You could talk about other languages you might use, or you might talk about more basic solutions like having a list of instructions and a calculator. And then at its highest level, you're going to talk about explaining why this solution is so good. You're at a higher level, we're starting to justify things. You didn't just throw this, you didn't just throw this idea together. You realise that this is a really good way of solving the problem, and you have to explain how that working has happened. This is the kind of thing that a top analyst would do. You're not just giving the client and the programmer your solution and just saying go with it, this is what you get. You're explaining why this is such a good solution, why this is the best. And you're going to talk about any constraints, any difficulties, anything that stopped you from making this even better. It could be the language you've been instructed to use. It could be the resources you have, the number of staff that you have all the time. Or perhaps you're in a lockdown and that makes it difficult to talk to the programmer and the client. So that's that higher level explanation of why you know that this is the best that could be done, not just any old project solution. Then you begin writing your program. So this is the core part, but you ideally have done the planning first. I recognise that very often people write the programme in this situation because they're experimenting, and then go back and write the planning. But what we should be doing is we should be planning first, then we write our programme, and then we evaluate. So here's the writing. So you have to make a programme. At its most basic, it can be quite a simple solution. It should include things, perhaps concatenation, or just manipulating the language a little bit. You should talk about what the input will be like and make the input so that it's easy for the user to put the information in, and easy for them to understand what the thing coming out is. You make sure it works, and make sure you include comments. Use that hash if you're using Python. Then you need to get your test plan that you did, your test table, and complete it. Show the results in that results column. And it's important to emphasise, tests that don't work are equally valid. You just say what you did to make it better. And to get your merit and your distinction, you should show that things have gone wrong and you have made it better. If you're going to be thinking a little bit higher, these are the sort of questions you should be asking. You should be talking to other people and showing your programme to other people. And then you should be asking them about how they find the programme. Does it solve the problem that you said it would? Is it usable? Do they feel comfortable using it? If not, get their feedback and make improvements and show how you have made improvements because of what your reviewers said. Perhaps they say it just doesn't, the calculation isn't accurate enough. Or perhaps they say that when you give out a number at the end, it isn't clear what that number means. Then, so that's your higher level thinking, getting feedback, making improvements and fixing faults and making it better and explaining how you've done that. And if you've been thinking at that depth of thinking, that higher level thinking, you could take it even further and take time to just make that programme the best it can be, and explain with evidence at screenshots to say how this programme is even better than the original that you started. How have you made it most maintainable? Have you put better comments in that make more sense? Have you used repeats that work better? How have you made it the most usable for the client, for the customer or the user? Remember, they're not programmers. So how have you made it so that they find it the easiest to use without having to think in a technical way? Have you made it so that it could be transferred to other platforms? And if not, why were you not able to? And the third part of this assignment gets you to review the project. This is a normal step in programming. What would normally happen is that you would have an analyst talk to the client to start with. That's your first part. You would pass that on to a developer, and then after the program has been written, a team of other programmers and analysts will come together and evaluate how well this program has solved the problem. This teaches everybody ready for future programming. This gives them it checks that the project works, and it also improves everybody's skills, and it makes sure for a larger team that they are building programs that work together and work as all in a similar way. So at your core, what you are going to do is state with screenshots the things that you said at the start, each of the things you said the program should have, and how you have shown that you have done that. The client needed a program that would do something or other, and here's a screenshot that shows I did it here. It also had to be simple to use, perhaps, and look, here's a screenshot showing simple instructions, for example. So this is the second, if you're able to think a little higher, review the design. You're not just, this did this, I did that, I asked for this, I did that. You're starting to judge how well this worked against your initial plan, against what you finished. And did you make any changes, and why those changes were needed? Now, these really are running on. They are one technique. They are one skill. So we're not really looking for one thing, then the other thing, then the next. We're looking for really, if you are working at the higher level, to extend this across. And at the highest level, we're looking that you can evaluate. That means you don't just do it, you are really able to see what's better and what's not so good. You evaluate your program. What do you like about it? What aren't you that happy about? And it's good, it's positive to say things you would improve further. That's not a negative, that's you growing. Show any changes that you made. Justify. Why justify? That means you've got to argue to your manager. Why did you make those changes? And what it was that you were stuck by that stopped you making it even better. And how would you take this program even further to make it completely functional? How would you extend it? How would you make it even better? Would you make it more graphic? Would you include images? Would you include some sort of check? Would you have some sort of way of storing that information off more permanently? How might you change the way you've programmed it? What language would you change it to? Perhaps this is a prototype. What language might you use now that would make it even more usable and fit for purpose? That's your very highest level thinking. So you're taking your overall evaluation, your broader evaluation at higher level. And I hope that explains to you in steps how this program, how this project should be written. So remember, it's made up of the planning, then the building, and then the evaluating. And there are 3 kind of levels. We want you to work at the core. We'd like you to add on to that core so that you're thinking at just a slightly higher level. And then if you can take that to the highest level and show that you understand where your skills are and where this is in relation to what it could be, that higher level thinking is where you go for those higher grades.